Product and Quotient Rules, Part 3. An important reminder that if you're asked to find f prime of a, be sure to find f prime of x before you substitute x is equal to a. So at the very least, make sure you're taking the derivative before substituting x equals a. Otherwise, you're going to end up taking the derivative of a constant, and that's not what we need. If f is a differentiable function, find an expression for the derivative of each of the following functions. So we want to find the derivative of y is equal to x squared times f of x, and this is a product where our first factor or function is x squared, and our second factor is this mysterious f of x. The derivative of y with respect to x is denoted as dy dx. So that's just the derivative of y. And this will be equal to the first function, x squared, times the derivative of the second function, well, the derivative of f of x is f prime of x, plus the second function, f of x, times the derivative of the first function. The derivative of x squared is 2x. We have a common factor of x between each of these, so we can write this as x times the quantity x prime of x plus 2 f of x. And this would be dy dx, the derivative of y. Now we want to find the derivative of y is equal to x over f of x, where this is a quotient. So the derivative of y with respect to x, dy dx, will be equal to our low d high, so the derivative of x is just 1, minus high d low, the derivative of f of x is f prime of x, all over low, so all over f of x squared. So this is equal to f of x minus x prime of x all over f of x squared. Now we want to find the derivative of y is equal to e f of x over 2x cubed. So we have a product rule within a quotient rule. So let's find dy dx by first looking at this. So we have low, which is 2x cubed, d high, so now we have to find the derivative of this e to the x times f of x using product rule. So that will be the first function, e to the x, times the derivative of the second function, plus the second function, times the derivative of the first. And the derivative of e to the x is still e to the x. So this was our little inside product rule. Now back to our quotient rule. So we have our low d high. Now we need our minus high d low. The derivative of 2x cubed is 6x squared, all over low, so all over 2x cubed squared. And then we'll need to simplify this a bit. So we have a common factor of e to the x. So this e to the x will be factored out to the front, and then we could factor it out all the way as well. We also have a common factor of 2 and a common factor of x squared. So this will be equal to 2 x squared e to the x times x, oh, here we go, times x times f prime of x plus f of x minus f of x, and we're left with 3 when we factor out that 2, so 3 f of x all over 2x cubed is the same as 4x to the 6th power. So we'd actually be able to simplify this a little bit further. Our 2 will divide out, and x squared will divide out. Which leaves us with e to the x times that guy over 2x to the 4th. And that would be the derivative of this function. Suppose that f of 2 is equal to -3. G of 2 is equal to 4. F prime of 2 is equal to -2, and g prime of 2 is equal to 7. We want to find h prime of 2. Remember, before you can substitute in this 2, we have to take the derivative first. So we have to find h prime of x before we can find h prime of 2. So this would be 4 f prime of x minus 3 g prime of x. No products or quotients here, luckily. And then we can substitute to find h prime of 2. So that'll be 4 times f prime of 2 minus 3 times g prime of 2, which will be equal to, well, let's see, f prime of 2 is -2, and that looks too much like division, so I'll just underline, and g prime of 2 is equal to 7, so we have 4 times -2 minus 3 times 7, so that's equal to -8 minus 21, which is equal to -29. And that is h prime of 2. Again, derivative before substitution. We still have the same f of 2, g of 2, f prime of 2, and g prime of 2, but we have a different h of x. Now h of x is equal to f of x times g of x, and we'll still find the derivative of h of x, h prime of x, before we do any substitution. F of x times g of x is a product, so we'll have to use product rule. So we have f of x times g prime of x plus g of x times f prime of x. So the first times the derivative of the second plus the second times the derivative of the first. So this actually just looks like the definition of product rule. Now that we've found the derivative, we can substitute. So this will be f of 2 times g prime of 2 plus g of 2 times f prime of 2. So that'll be -3 times 7 plus 4 times -2. So this is equal to -21 minus 8, which is coincidentally another -29. This is entirely a coincidence. Now we want to find h prime of 2 if h of x is equal to f of x over 2 plus g of x. This is a quotient, so it will require quotient rule. So h prime of x will be equal to low, which is 2 plus g of x, d high, so the derivative of f of x, which is f prime of x, minus high, which is just our f of x, d low, so the derivative of 2 plus g of x, which is 0 plus g prime of x, all over low, so all over the quantity 2 plus g of x squared. And now we can find h prime of 2. So we have 2 plus g of 2, which is equal to 4, times f prime of 2, which is negative 2, minus f of 2, which is negative 3, times 0 plus g prime of 2, which leaves us with 0 plus 7, which is 7, all over 2 plus g prime of 2. Oh, no, sorry, just g of 2. So that's 4 squared. So 2 plus 4 times negative 2 gives us negative 12, plus 3 times 7 is 21, all over 2 plus 4, which is 6 squared, so 36. So we have 9 over 36, which simplifies to 1/4.